Right. So 577 is a three-part. Metallurgy we have already seen. Okay, metallurgy, then only we started section 9. So we will go to the welding and the NDT part. I will go from first page starting. Otherwise, we have to jump here and there. Welding, generally, there may be 2 or 3 questions. NDT, it is clubbed together with the section 5. I told NDT, they are asking 8 to 10 questions. It is both 577 as well as section 5. Now, welding, what are the things you should know? You want to play process video? No. Process, what is the SMAW, GTAW? There is a 15 minutes video, lengthy video. No, okay. Now, generally, they will ask advantage and limitations of the process and some welding related terminologies. So, generally, how the process work, except GMAW only, they will ask how the process work. Other process, advantage and limitations. So, what are the process you should know? SMAW, GTAW, GMAW, FTAW, SEAW, stud welding. Okay, we will go through it. If you want to play any video, I will play video. Okay, so please take. We'll go from terms and definition. The first page, highlight this 2 line. The RP does not require all wells to be inspected, nor does it require wells to be inspected to specific technique and extent. Mark it as a closed book question. So as per 577, it is not mandatory to inspect all wells. Only a representative number you have to inspect. Mark it as a closed book. And this are not, it's the same only. That's why I'm skipping. 2201 already you know that. No need to highlight. Then straight away go to the page number 3. What is ACFM? This is the definition of ACFM. An electromagnetic inspection technique that can be used to detect and size surface breaking, in some cases near surface, both magnetic and non-magnetic. You remember 510 class during I told you, the difference between ACFM and MP is MP we can use only in ferromagnetic, ACFM we can use all conductive material. Then what is actual throat? That is a closed book question. Shortest distance between the weld root and the face of the fillet weld. Arc blow, deflection of the arc from its normal part due to magnetic. That is closed book. Then artifact, recently asked. What is artifact? Film marks due to processing or handling. This is indication on radiograph that may be caused by damage to the film before, during, or after processing. Recently asked question, artifact. Then please go to the next page, page number 4. Burn through. Hole or depression in the root bead of a single groove weld due to excessive penetration. That is closed book. Buttering. Buttering means when the root gap is, if you have a large root gap, for example, root gap is 20 mm. Well, we cannot weld that one. So you have to reduce the root gap. We will weld on the face of the edge preparation. That is called the buttering. Surfacing variation, depositing surface metal on one or more surface to provide metallurgically compatible weld metal for the, this is the key word, subsequent completion of the weld. That is called buttering. Then what is CDW? Highlight this one. Top bead, temporary bead, welding technique used to obtain controlled grain refinement and tempering of the underlying heat affected zone. So that is the definition of controlled deposition welding. This also recently asked. This is the definition of controlled deposition welding. Then corrosion specialist, person acceptable to the owner user who has knowledge and experience in corrosion damage mechanism, metallurgy and material selection and corrosion monitoring technique. That is open book question. Then defect, type of discontinuity that by nature accumulate a defect, render a product unable to meet the minimum applicable acceptance standard. That is closed book question. Now, briefly, a little bit about the welding process. As per American Welding Society, what is the basic requirement for the welding? We need a power source. Okay. Why we cannot weld directly from our standard power supply? Because these are high voltage power supply. So what is the voltage we are getting now? 230 volt. But welding requires a low voltage, high current power source. We have to reduce the voltage, but we need a higher current, increase the current. Now, so what are the power sources available? Transformer, rectifier, generator, inverter. There are 4 types of power sources. What is the difference between this? Transformer, AC to AC, only thing reducing the voltage, increasing the current. So transformer output is again AC only. DC, AC to DC. Then that is rectifier. What is generator? Directly generating the DC. Inverter, DC to AC. Okay. Now, first thing, what is the difference between AC and DC power source in welding? Suppose this is my power source. For example, this is a AC power source. So we will connect one lead to the electrode. So electrode, another lead to the base metal. Here, how much heat will be generated? 50% here, 50% here. What is alternating current? Every second, 50 to 60 times, the positive negative will change. There is no fixed positive negative. That's why I didn't mark here plus or minus. Now, what is the advantage of AC equipment, a welding equipment? The advantage is it is a very cheap equipment. You can see all our what your domestic welding works. We are using a small transformer. But the problem is, this is a major disadvantage is for high quality works. Welder does not have the where to focus the heat because it is almost 50-50. So we need a DC. If we go to the DC, so DC in direct current, if you go with DC source, positive and negative are fixed. If you connect your positive hose, positive lead to the electrode, and negative to this base metal, where the more heat will be generated on the positive, 2/3 of the heat. 2/3 means 66% heat here, 33% heat here. Now, this arrangement is, what is this arrangement is called DC EP, direct current electrode positive, or another name of this is a reverse polarity. Reverse polarity. So, where we will go for this type of equipment, where you want to melt the electrode, because electrode will have 2/3 of the heat. So, which of the process we are melting electrode? SMAW, except GTAW, SAW, GMAW, FCAW. This all process generally we will go for this. There are exceptions are there. Forget about the exception rule. This is the rule. Opposite is, suppose I have a DC, negative here, positive here. Negative is connected to the electrode, positive here. Now here it will be only 33%. Here it will be 66%. This arrangement is called as a DCEM. Direct current electronegative, or it is called as a straight polarity. Where we will use this arrangement? GTAW, where you don't want to melt the electrode. In gas junction arc welding, the electrode is a tungsten. Only filler rod we have to melt it. We will go like this. Okay. Now the next one is first power source. This is briefly I'm explaining welding because welding is like a very big subject actually. Next one, we need a protection to protect the weld from the atmosphere. Again, there are 2 types of protection. One is gas shielding. Which process use gas shielding? GTAW, GMAW, FCAW can have gas shielding. Without gas shielding also you can weld. What is the advantage of gas shielding? gas shielding process are considered as a low hydrogen process because there is no flux, there is no moisture. What is the disadvantage of gas shielding is because gas in the windy condition we cannot weld. It will not give sufficient protection. Another one, we need a very clean surface for gas shielding process. If the surface have a rust, then there will be porosity will come. So opposite is, so gas shielding we are using GTAW, GMAW, FCAW. FCAW without gas shielding also we can weld. The second type of shielding is a flux shielding. Just opposite flux shielding. Flux shielding are never considered as a low hydrogen process because wherever there is a flux, it can absorb moisture. Moisture is water. Water is H2O. Naturally, hydrogen will go in. But what is the advantage? Even rusted surface we can weld, they will come out as a slag. Even a windy condition, we can weld it. So which of the process we are using flux? SMAW, FCAW, SCAW. That is about the shielding. Now coming to the deposition rate. Deposition rate related to the protection. Which process have the least deposition rate? GTAW, then SMAW, then GMAW, then FCAW, then SCAW. Okay. Now finally, the process can be classified into 4 groups: manual, mechanized, semi-automatic, automatic. What is manual means? The welding involves 2 reactions actually: feeding of electrode, movement of electrode. If both are by human, manual. For example, SMAW. One is by human, another one is by machine, semi-automatic. Example, GMAW, FCAW. Both are by machine, but under the operator control, that is called mechanized. Example, submerged operator. Automatic means everything will be taken care of by machine, that is robotic welding. That much sufficient. So if you want to write anything, you can write. Just briefly, and welding, they're asking only 2 or 3 questions. Okay. Right. So please go to the code book. So direct current electronegative, highlight this one, DCEN, another name is straight polarity. Direct current electrode positive, DCEP, that is reverse polarity. So you should know DCEN means straight polarity, DCEP means reverse polarity. Then discontinuity, interruption of the typical structure of the material such as lack of homogeneity in mechanical, metallurgical or physical characteristics, close book. And distortion, this is recently asked. This is recently asked open book. Change in shape or dimension, whether temporary or permanent, or a part of result of heating or welding. That is open book. Then these are not important. Then imperfection, again another important, recently asked. They will specifically, the question itself they will give like this: discontinuity or irregularity in a weld or deviation from the indent geometry. There's a detectable by methods outlined in 577. The question itself they will give like that, because here it is given in this standard. The standard is for exam question itself, they will give 577. When you see the word in 577 means answer is imperfection. Okay, so the question will be asked like this only: discontinue or irregularity in a weld or deviation from the indent geometry that is detectable by methods outlined in this as per 577 is called as. Answer is imperfection. Why I am specifically saying the definition now they changed actually. This imperfection before it was called as a flaw. Now they change it to imperfection. That's why they are specifically saying as per 577, because some codes still there. So they are defining as a flaw only. That is open book. Then indication, highlight this one, indication, close book. Signal of discontinuity in the material under NDE. The next page, overlap. 3.1.55. Protrusion of weld metal beyond the weld row, weld toe or weld root. It is called overlap. Then these are not important. Page number 10. Throat, theoretical throat. Distance from beginning of joint root perpendicular to the hypotenuse of the losses triangle. The note is important. The dimension is based on the assumption that root opening is equal to 0. So when they are designing for fillet weld, there is no root opening. Then what is undercut? That is another important, page number 11. Groove melted into the base metal adjacent to the weld toe or weld root and left unfilled by weld metal. That is undercut. Close book question. The next page, weld toe, junction of the weld face and the base metal. That is also important. Where the face and the base metal meet, that is called weld toe. Now, SMAW. Right away we will go to the advantage and limitations. See, SMAW is normally used in welding process. It's normally called arc welding. So arc is initiated between flux coated electrodes. Flux, three processes are using: SMAW, FCAW, SCAW. SMAW flux coated, FCAW flux cored. Cored means flux will be inside a tube, whereas SCAW is flux covered. Flux will cover the, so there is a difference. SMAW, what is the function of flux? To initiate the, and okay, so initiate the arc, maintain the arc, to add alloying elements, all these things. These are not important. What is the advantage of SMAW? First advantage, it is a most widely used process, very cheap process. The least cost process is SMAW. Second one, we can use all materials. Third one, even inaccessible areas, you can see people are bend the electrode and they can weld it. Inaccessible area, we can weld it. Consumables are easily available. These are the advantages. What are the limitation is, it is not a continuous welding. Every time electrode you have to change and you have to remove the slag in between. So, and the deposition rate is more than GTAW, that's all. It is not the high deposition rate. So deposition rate least is the GTAW, next is the SMAW. These are the disadvantages. So highlight this one, advantage and limitations. Advantages highlight. Following are some commonly accepted advantages. The equipment is relatively simple, inexpensive, and portable. The process can be used in areas of limited access. These are closed book. Process is less sensitive to wind and draft than other welding process. Process is suitable for most commonly used metal and alloys. The level of training and experience required is lower than other welding process. Limitations. For deposition rates are lower than for the process such as GMAW. Slag must be removed from the deposited weld process. Now we will go to the GTAW. If you see GTAW, the arc is initiated between non-consumable tungsten electrode and the base metal. Filler rod can be added separately. Without filler rod also you can weld. That is called autogenous welding. Generally, other process we are using direct current electrode positive. Here we are using direct current electrode negative. But aluminum, magnesium, AC is the preferred. Alternating current is the preferred. Now, what is the advantages? It is a clean process. Very good for the root pass welding because we can get a uniform fusion and penetration. What is the disadvantages? The deposition rate is very low. And the high welder fatigue welder will be easily tired. Why? Why GTAW welder cannot weld continuously? Huh? Yeah, only GTAW welder மட்டும் tired ஆகுறாரு. மத்த வெல்டர்லாம் tired ஆகுறது. Yes, they are using both hands simultaneously. Other welders will hold only one hand. ரெண்டு இது continuous, we have to concentrate both hands, so that's why they will get tired easily. Another one is tungsten inclusion is the problem with only GTAW. Okay, so please take GTAW first line, process that generates arc between a non-consumable tungsten electrode and the weld pool. And this three line, alternating current provides catalytic cleaning that removes refractive oxide from the surfaces, which is necessary for welding non-ferrous such as aluminum and magnesium. Highlight that one. Then page number 17, advantage of GTAW. Highlight this four lines. Produce a high purity welds, generally free from require little post-wet cleaning, allows excellent control of root pass and weld penetration, can be used with or without filler metal depending on application. These are this one. Limitation, the first one is important, close book. Lower deposition rate than the rates possible with the consumable electrode arc welding. This is the lowest deposition rate, least deposition rate. That is closed book question. Then we'll go to the gas material GMAW. Now, what is GMAW? Arc is initiated between continuously fed wire. If you are not familiar with welding, there are a lot of YouTube videos are available. You can check the videos. Okay. And the base metal, like we call it as a gun. And the shielding is provided with a inert or active gas. We can use CO2 also. Okay. First thing, this is, even though it is called a single process, we have 5 modes of metal transfer. How the metal is transferred? GMAW short circuiting, GMAW modified short circuiting, GMAW globular transfer, spray transfer, pulsed arc. Out of this exam point of view, 2 are important. One is the GMAW short circuiting. What is meant by short circuiting? Every time the electrode will touch and weld. So the arc is not continuous. When you touch, there will be no arc. Where we are using a GMAW short circuiting for thin sheet welding. Generally, the automobile industries, for the car body welding, they are using GMAW short circuiting. But the problem is, when you are welding a thick plate, because of low current, there may be a lack of efficient problem. You remember yesterday we have seen in section 9, GMAW short circuiting welders cannot be qualified by radiography. The reason is lack of vision problems. Modified short circuit is the recent development to avoid the lack of vision problem. Now, what is meant by globular transfer? The molten metal will have a globe shape, round shape, bigger than the electrode diameter. globular transfer is the highest deposition rate, but it is the least desirable product. It is not preferred because it will create lot of spatter and the weld appearance will be very bad. Even though high deposition rate, generally it is not preferred. Then spray transfer means very fine drops. Okay, a process due to the acceleration of fine drops. Discrete, they will call it as discrete drops. Spray transfer have very good deposition rate, but the problem is it cannot be welded in all positions. It can weld only in the flat and horizontal positions. Now, GMAW short circuiting we can use in all positions, but we cannot use in all thickness. That is suitable for only low thickness. Spray transfer you can use in all thickness, but we cannot in all positions. So they combine together. That is called as a spray transfer, pulsed arc. Pulsed arc means the equipment automatically will control the current based on the thickness and the position. So these are the key points you should know. Okay, so please take GMAW, highlight this first line, arc welding process that produce an arc weld in a continuously fed filler metal under the weld pool. Highlight the first line. Then next, short circuiting. These 4 lines are important. This is closed loop. GMAW short S encompasses the lowest range of welding current and electrode diameter associated with the GMAW process. This process produces a fast freezing weld pool that is generally suited for joining thin section, out of position welding or root passes. Due to the fast freezing, there is high potential of lack of sidewall under interposition when welding thick wall equipment. That is closed book. Then these are not important. Next page, globular transfer. Page number 20, highlight the first paragraph. The advantage of this transfer method is the relatively low cost when carbon dioxide used and high deposition rate. And the second paragraph, first 2 lines are closed. The globular transfer mode is often considered the least desirable of GMAW transfer modes due to its tendency to produce high heat, poor weld surface, and weld spatter. That is closed book. Then spray mode, first line is very important. The spray or transfer mode results in a highly directed stream of discrete drops accelerated by arc forces. The exam question, generally they are asking which of the following process uses highly directed stream of discrete drops accelerated by arc forces. Answer is GMAW spray transfer. Then the 5th line. At high deposition, the welding process may produce a weld pool that is too weak to be supported by the surface tension, which limits the use of welding process in the vertical and overhead. So very difficult to weld in the vertical and overhead. Then pulsed transfer, highlight the 2 lines. Pulsed arc GMAW developed to overcome the thickness and the welding position limitation of the globular, spray, and the short circuit. Then advantages not liquid. Go to the limitations. Limitations. Highlight the ABC. The welding equipment is more complex, more costly, and less portable than for GMAW. The arc must be protected from air drops and can disperse the shielding gas. When GMAW is processed, the welding is more susceptible to lack of adequate vision. As a result, ultrasonic is generally employed as the inspection method because the probability of detecting LO is rather low for radiography. That is closed book question. FCAW, same GMAW, only the electrode is a tubular. Now, here 2 things are important. What is the advantage of FCAW? The welding will be very smooth. It can be used all materials, but there are 2 major disadvantages. First one, if you are going for a root pass welding with the FCAW, you remember we have seen one retainer video. That is FCAW. We should have some backing. Without backing, you cannot weld both. Another problem is there are 2 types of FCAW, with the gas shielding, without the gas shielding. When you are using without the gas shielding inside a vessel, these are called confined space. Exhaust is mandatory. Otherwise, welder will have a breathing source because it will replace all oxygen. Okay, highlight this one. FCAW is a welding process that produces an arc between the continuously fed tubular electrode and the weld pool. The process is used with a shielding has evolved from flux contained with a tubular electrode with or without additional shielding. Then go to the page number 24, advantages. Highlight the AB, metallurgical betterment that can be derived from alloying elements, flags that support and shape the weld bit, allowing for a slower cooling rate. Limitation B, D are important. Close book question. B, self-shielding FA generates large volumes of welding fumes and requires suitable exhaust equipment. D, backing metal is required for root cause. B and D are close book question. Now the next one is submerged arc welding. What is the submerged arc welding? So we are using the electrode and the flux is covered. What is the advantage? Very high deposition rate compared to other process. Limitation, it can use only in the flat position. Okay. Highlight this one, first line. SAW is an arc process, welding process that use arc between a flux covered bare metal and electrode and weld pool. Then advantages. It provides a very high metal deposition rates. It produces a repeatable high quality welds. Limitation A, power supply capable of producing high ampere 100% duty cycle, that is open book. B, the weld is not visible during welding, that is important. And D, the process is generally limited to sharp application and flat position. Then stud welding. So this is the stud welding.
Large diameter fasteners, porous and thicker base metals. Cut fasteners are available in many sizes and shapes. A fastener and ceramic ferrule are loaded into the welding gun and firmly placed against the work surface under spring tension. Upon triggering, the welding gun automatically lifts the fastener from the base metal and initiates a controlled electric arc, which melts the end of the fastener and a portion of the base metal. At the precise moment the fastener and parent metal become molten, and the fastener is automatically plunged into the work surface. The metal solidifies, creating a high-quality, full-penetration, cross-sectional weld in seconds.
Okay. Right. So stud welding, highlight this one, first line. Stud welding is an arc welding process that generates an arc between a metal stud and a similar part at the workpiece. That is important. Then limitations are important. A, the process is primarily suitable for only carbon steel and low alloy steels. The process is specialized to a few applications. These are open book questions. Then these are not important. Just to go to this page number 31. This is the P number table. Just to mark it as a open book because this table already be marked in section 9 also. Page number 31. P number table because section 9 will repeat here also. So no problem. Then F number, highlight these 3 lines. The electrodes and the welding rods are assigned F number to reduce the number of welding process performance. The F number grouping are based on the usability characteristics, which fundamentally determines. Now, this also it asked, you can answer from here also open book actually. Welders who qualify one filler metals are qualified to weld all filler metal having the same F number. And in the case of carbon steel SMAW process, may additionally qualify to weld the electrodes having the lower F numbers. For example, welder qualified 7018 F4 is qualified to weld with all F4 electrodes plus F1, F2, F3 electrodes with the backing limitation. However, other F numbers such as F6 qualify for that F numbers alone. This all we have marked there also, but it is given here. Then A number, highlight this one. To minimize the number of welding procedures qualification, steel and steel alloy are also grouped according to A number. The A number grouping is based on the chemical composition of deposited welded metal. That is closed book question. Then consumable storage and handling. See, you have to reback the electrode if you are not vacuum packed electrode. Now, rebacking, when you are doing backing, what we normally call it as a backing, low hydrogen electrode should be rebacked separately to avoid hydrogen pickup. And when the electrode is cooled, we have to again reback it, but it become wet, it should be discarded. Discarded means you have to break and through. Okay, highlight this one. 5.7. This 3-2 lines. Some welding consoles that are slightly damp can be reconditioned by backing in separate special oven, that is closed book. And the last line, any electrode or flux that becomes wet should be discarded, that is closed book. Then these are not important. So straight away go to the page number 47. Page number 47, highlight this one. Unlike the WPS and the PQR, the welding performance qualification is only limited by essential variables. That is closed book question. Then page number 50, NDT. So NDT, whatever additional we will see here. Okay, because we already see in section 5. Just we will additional. Please go to the page number 51. See, there are 4 tables are there. Before going this table, page number 51. First, what are the different type of joints we have? So it is given in annexure actually. We'll go to the annexure and come back. So please take page number 132, 132. Annexure A. See, we have 5 types of joint as per AWS. What are the type of joints? Butt joint, corner joint, T joint, lap joint, and the edge joint. This joint we have to remember. These are 5 types of joints. Butt joint, corner joint, T joint, lap joint, and the edge joint. Now, why I should know these joint types? Now they are regularly asking open book, which NDT is suitable, what type of joint. Open book, there is a table is there. For that, you should know what is the joint. Now, next one is, what is the difference between weld symbol and welding symbol? Weld symbol na enna, welding symbol na enna. Yeah, weld symbol is the just edge preparation, whereas welding symbol will have all details. Now there are 2 questions asked in 2 different exams. Which is the mandatory part of the welding symbol? Weld symbol they will not ask. Answer is the reference line. Second one, where the process and NDT details marked in the welding symbol. Answer is at the tail. Okay, where it is given, just is another 2 pages. Please go to the page number. This is the welding symbol 134. Just write here. This is called a reference line. Reference line is mandatory part of welding symbol. This is the reference line. And right here, welding process NDT details marked in tail. These 2 are asked in 2 different exams. Page number 134. Okay, right. If you go to the next page, you can see this. Oh, see this one. This already explained. What is the electrode classification? So one is all, two is plot. You already wrote. This is the GMAW, GTAW, PAW. This one. This all close book because you should know this electrode classification. Then finally here there is a mistake here actually. Page number 1 that T is not position. There is a error here. It is tubular. T cut and write tubular. T is not position. It is a tubular. That's all this annexure. So T for tubular. So please go to the page number 51. Please take page number 50. Not 51. Yes. 51. Now they are given some tables. Generally, any one of the tables there will be one open book question. So first table is what are the location of the discontinuity? Mark it as a open book. For example, this was asked in the exam. Which discontinuity will occur at the weld toe or root surface at the weld metal zone? Answer is overlap. You have to refer the table and answer it. But this is older version. Recently, they are asking based on the type of joint only. So this table is very important. 53. Now, recently, all exams, they are asking this question. Which NDT method is applicable? What type of joint? You can see here. See, A means applicable, M means marginally applicable. For example, T joint. UT is applicable, PT, MT, VT, LT, ACFM applicable, whereas ET and RT are marginally applicable.
Marginally applicable.
But with a lot of restrictions. If you take lab joints, only PT, MT, VT, LT are applicable, others are marginally applicable. So you have to refer it and answer. Which of the following NDT methods are applicable for T joint? So they will give 3 marginally applicable, 1 applicable. So you have to choose it from. The next table, which discontinuity and detected by what NDT method? Just to mark it as open book. The next table, what is the practical solution for the discontinuities? That is also marked as a open book. Then we'll go to the page number 55, visual examination. The visual, we have not seen section. Visual, we should know some 3-4 points. First, the visual inspector I2 should be tested every year. He should be able to read J1. Other NDT is J2. Then what the distance from the surface and your eyes during visual examination? 6 inch to 24 inch, minimum 6 inch, maximum 24 inch, angle more than 30 degree. Then you can use the optical aids as well as the mechanical aids during visual. What are the optical aids? Lighting. Lighting, what should be the lighting at the surface? 1000 lux. Mirrors, magnifiers, boroscope, fiberscope. These are optical aids. Mechanical aids are weld gauges. Okay, so please highlight this one. BT is the most extensively used NDT method for weld. That is closed book question. You remember I asked during the class, which is the NDT most widely used? Answer is the visual testing. It is given here. It includes, say, the direct or indirect observation of the exposed surface. Direct which is conducted when access is sufficient to place 6 inch to 24 inch. That is on the surface, not less than 30 degree. Highlight that also. That is the VT, the distance between eye and the surface. Which one? Size of the letter, which there is one called a Jaeger chart. J1 is a small letter. You should be able to read that small letter. Even if it is small defect, you should be able to identify. J2 is a little bit. Not less than 12 inch. Not less than 12 inch. At least 12 inch, you should not keep very close. No, that is long. No. See, there are 2 types of vision test. Near vision acuity. Okay. Another one is the far vision acuity. Doctors are testing far vision. Far vision is not required for inspection. Because inspection, what is the maximum distance you can keep? 24 inch. Near vision only. Near vision, the doctors also have in the chart. They ask you to read it.
Other than that.
That is far vision, for your far vision.
We are not reading. Right.
No, that is for far vision. See, far vision, near vision required for the reading purpose. Far vision required for the normal. Because if you have far vision problem, which one? Yes, if you want only in the inspection or you are using laptops, near vision is sufficient. But if the problem with the far vision is during driving, you are driving your own vehicle, you have to go for the specs. That's why specs they will give for both actually. But if you have a far vision problem more, you have to continuously wear the specs. Otherwise, you will have a headache problem. Near vision அப்படின்னு சொன்னா அந்த ரீட் இப்போ நான் நியர் விஷன் தான் எனக்கு ஃபார் விஷன் இஸ் வெரி லெஸ் ஸோ அதனால ஐ எம் நாட் வியரிங் கண்டினியூஸ் ஸ்பெக்ஸ் ஒன்லி ரீடிங் மட்டும் தான் இருக்கும் ஓகே தென் go to the next page 56 persons are required to document the annual completion of J1 Jagger type eye vision test with or without a correction. That is closed book question. Then this is important. What are the optical aids? Optical aids in the visual inspection: lighting, 1000 lux, mirror, magnifier, borescope, and fiberscope. These are the optical aids. And the mechanical aids: steel ruler, vernier scale, highlight the heading. So this is closed book. The following is not an optical aid. So you should know what are the optical aids. So optical aids are lighting, 1000 lux, mirror, magnifier, borescope, and fiberscope. What are the mechanical aids? Steel rules, vernier scale. You can go to the next page. These are not important, but these two are important. This is asked in the last year. Bridge came cage. The C-shape examination people are using can be used to determine the weld preparation, angle prior to welding, can also be used to measure excess weld metal, depth of undercut. That is open book. And this also open book. QT fillet weld gauge, measure the angle of vertical member. That also open book question. You can see here, this is the bridge came cage, weld gauge, and this is the QT fillet weld gauge. This is the QT fillet weld gauge. Right. After that, MT, we already seen. So please go to the page number 66. Demagnetization. See, when demagnetization is required, if there is any residual magnetism after MPI, it can interfere with your welding and it will not allow you to weld. That is called of the arc blow. Then you have to demagnetize. Highlight this one. If residual mag field is left in partially completed weld, this field may deflect the weld arc and make it difficult to control the weld deposit. That is closed book. Now, what is ACFM? We know alternate current field measurement. What is the advantage of ACFM? It is a non-contact technique. No need to touch the path. Just to go nearby. That's all. Temperature up to 900 degrees Fahrenheit we can use. It is used at the in-service to detect cracks in the inaccessible area. For example, cracks in the holes. But what is the disadvantage of ACFM is we need a high skill operator. Highlight this one. ACFM technique is a electromagnetic non-contact technique that is able to detect size, surface breaking imperfection in a range of different material and through coatings of varying thickness. This technique can be used for inspection of complex geometries such as nozzles, ring grooves, and grind wood. That is closed book. The last line, however, it is less sensitive and more prone to operate error than wet fluorescent MT. ACFM is used to evaluation of monitoring the existing cracks. PT, nothing important. Then coming to the eddy current, page number 69. See, eddy current is a very large subject, but only one thing you should know. You know MPI, what should be the defect orientation respective of flux? Parallel or perpendicular? Perpendicular. Here, eddy current should be perpendicular to the defect, not this one. So highlight this one. This is open book. Similar to MT, this technique provides the greatest probability of detection when the circulating currents are perpendicular to the discontinuity. That's not. Okay. Then RT. RT, we have some additional things, just one will highlight it. Highlight this one. The NDT examiner who perform film interpretation, evaluation, reporting shall be certified minimum level 2. That is closed book. Then please go to the page number 72. This is important. Course. Highlight this one. Iridium 192 is normally used for performing radiography on steel with a thickness of 0.25 to 3. You have to remember this. 0.25 to 3 inch. Iridium 192. Cobalt 60, 1.5 to 7 inch. That is important. Close book. Iridium 192, what thickness you can radiograph? 0.25 to 3 inch. Cobalt 60, 1.5 to 7 inch. Now, another one is, what should be the minimum film width? The recommendation is a weld width plus 3/4 inch on both sides. First one. How much you have to keep overlap? Continuous film, minimum 1 inch overlap. Second one. Then what films you have to use? Either class 1 or class 2. That means medium and slow films are only allowed in the industrial radiography. Fast films we are used only in medical radiography. So highlight these 3 lines. Although digital recording of the radiograph sometimes used, radiograph film class 1 or 2 is extensively used in the industrial RT. The film is required to be in sufficient length and width to allow minimum 1 inch on consequently circumference exposures and 3/4 inch on either side of the belt. That is closed book question. And film processing, this is again closed book. Exposed film can either be manually or examined by is automatic. Typical development time is 5 to 8 minutes at 68 degrees Fahrenheit. Then these are not important. Then please go to the page number 75. See, suppose they are asking which of the following discontinuities RT can miss or RT cannot detect, means answer is crack, lack of vision, lack of penetration. Generally, RT easily detects voluminar defects. Voluminar means slag, porosity, undercut. This all they will easily get. So highlight this one. This one. For example, rounded indications such as porosity, slag, and inclusion have a much greater probability of detection than planar indications such as cracks, lack of vision, or overlap. A weld crack is generally tight and not always detectable by radiograph. That is closed book. Then how much magnification you should use during interpretation? Highlight this one. Low power magnifying devices 1.5 to 3x also be used to aid film interpretation and evaluation, but high magnification enhance the graininess. That is closed book. Yeah. Now, you remember I told there is a formula is there. What is the density formula is? Log IO by IT. Clear film means it is a purely white. That is zero density. The density is 0. Highlight this one. Film density is the quantitative measure of film blocking. Clear film has the 0 density. Exposed film allows 10% is called 1 density. 2, 3, 4 means 1%, 0.1%, 0.01%. Just to highlight. Then page number 76, last paragraph. In application where quality of final product is important for safety or reliability, more than one qualified interpreter should evaluate the radiograph. So critical, 2 people should evaluate the radiograph. That is closed book. Critical ஜாயின்லாம் இருக்குன்னு வச்சுங்க, 2 பேரும் இன்டர்பிரட் பண்ணணும். எதுக்குன்னா மிஸ் பண்ணிடக்கூடாது ஒரு எல்லாத்துக்கும். Now we will go to the ultrasonic. See, we have seen in section 5 only thickness gauging, but ultrasonic equipment display many types of display, but important is 3 A, B, C. What is A scan? See, this is the, see, for example, you have a defect like this in a material. A scan is the signal. So the x-axis gives the distance, depth of the defect. The y-axis gives the amplitude, severity of the defect. This is called a B-scan, how it looks. This is called a cross-sectional view. This is a closed book question. B-scan will give the cross. You can see the defect, actual defect, how the screen will look like. C-scan, same defect, will give you a plan view, top view. This is a C-scan. So B-scan cross-sectional view, C-scan top view. These two things you have to remember. So highlight from here. Page number 84, this one. A-scan is the most common display type. It shows the response along the path of the sound beam for a given position of the probe. It shows the amplitude of the signal coming from the discontinuity way as a function of time. That is the keyword. Which of the following display shows amplitude of the signal for coming from the discontinuity as a function of time? Open book question. Answer is A-scan. Only A-scan. They will give A-scan, A-scan and B-scan, A-scan and C-scan. No, it is only A-scan.
Keyword amplitude.
ஆமா y-axis வந்து ஆம்ப்ளிடியூட் தானே சிக்னலோட சிவிஆர். The next page, this two are closed book question. The B-scan display shows the cross-sectional view. B-scan display shows the cross-sectional view of the object, and the C-scan display shows the plan view of the object. These are closed book questions. Then after that, please go to the page number 91. See, when you are calibrating the equipment, not a step edge, you know, calibration block, reference blocks, they should be the same material, approximately same thickness, and the same heat treatment conditions. If they are post PWST, means you have to use a PWST block. Another one is when you have to calibrate the UT equipment, it is not thickness gauging, it is a equipment. Before start of the exam and at the end of the exam. Because these are only knobs. Some people just rotate it, then the calibration will change. So you have to check at the end of the shift also. Next one is important. In between, if you are changing the probe, you have to check the calibration. If you are changing the operator, you have to check the calibration. And if you are changing the cable, you have to check the calibration. Again, this question was asked like that. Which of the following does not require calibration recheck? Option A, change of the operator. Option B, change in ambient temperature. Option C, change in cable. Option D, change in search unit. Which is answer? Ambient temperature. Change in temperature will not recalibrate because if you start in the morning, so when you are going, ambient temperature will continuously change. But we will not check the calibration for that. Okay, highlight this one. The first three lines. The reference standard should have the same composition and heat treatment as the product being examined. It should also have the same surface condition of the part being examined. The reference standard should be an acceptable size and have known reflectors. Then this paragraph is very, very important. Calibration system check are required to be performed prior to and at the completion of examination. In addition, a system check is required with the changes of the search unit, cable, examiner. If any of these changes, we have to change the search changes. Then, and after a specific time frame, then this is also important. Temperature of the calibration should be within 25 degrees of the part. If the so, what is the maximum temperature difference allowed is 25 degrees Fahrenheit. Mark it as a closed book. Right. Then examination coverage, page number 93. So highlight this three lines, 8.9.5. Each pass of the transcript should overlap the previous at least 10% of the transmitted element dimension. The rate of search should not exceed 6 inches per second. These are standard UT requirements. That is closed book question. So that's all. After all harness test, Metallurgy we already completed.